Yeah. How are you guys doing? How are we doing? I'm good. I can't complain. Eh? I can't complain. So for today, we are obviously now in Learning Unit 3. I did tell you guys that we'll be doing Learning Unit 3 next time we meet. So today we won't do too much of exercises because we are going to be primarily just introducing what is going on in Learning Unit 3, okay? And I did give you guys homework to go and read or go through the slides for Learning Unit 3. So most of you should know that Learning Unit 3 is descriptive statistics, okay? So let's get into it. Okay? I'm going to have to do this manually today. Okay. So these are the key things that we must take out of this learning unit. Okay. These are the key things that we must take out of this learning unit. All right. We need to identify tools to summarize data. Okay. And we learned earlier on that data is just raw information, unprocessed. Okay. And then we need to present data using appropriate graphs. Okay, a lot of this is actually going to be revision for you because in high school or in primary, you played around with a lot of graphs, which you will see again today. Okay, so we will just be skimming through a lot of this stuff, okay, because it should be familiar and not brand new to you, okay? And then it's just a lot of information to kind of give you the gist of what is going on. But otherwise, there isn't too much to it. Then thirdly, the third learning outcome there is identify the features that describe and summarize data numerically. Okay, we already know that we have categorical data and then we have numeric data. Differentiate between grouped and ungrouped data. Okay, this is something we probably were doing unconsciously when we were in primary or in high school. And then compute, interpret measures of location. You'll see again there, somebody was mentioning about median, mode, and whatnot. I was just eavesdropping there. But yes, you'll see that also those measures of location or measures of central tendency are familiar as well. Relative standing, you have dispersion, you'll see that as well. And then shape for ungrouped data and grouped data. Okay, but let's jump straight into it. Okay. All right, so again, the key focus of what we're doing here is so that we can make decisions. Okay, and sometimes we have so much information that it's easier to look at it from a graph so that it summarizes the information or the data, all right? And then we just interpret what's on the graph so that we get an overview of what we are looking at. So here, categorical frequency table, okay? So here we're looking at a single categorical variable. And remember, categorical, we're talking about non-numeric data, all right? Expressing the counts as a percentage makes them easy to understand, interpret, and explain, okay? So if you've ever looked at a bar chart, you know that bar chart and a pie chart, you're looking at non-numeric information, okay? A few slides down, we'll have a look at what we are talking about. So here, right here, they've obviously put together our information, all right? And here they were looking at preferences in terms of your grocery stores. So you've got your Checkers, your Pick and Pay, and you've got your Spar. And there you've got the total people that were surveyed is 30 in red under there. And then obviously, you've got how many people preferred Spar, how many preferred Pick and Pay and Checkers. Okay, right. And then there you've got your bar chart and then your pie chart as I communicated earlier. All right. So can you see it's a whole lot more easier to look at this, right? Because immediately you can see, okay, majority people prefer. What do they prefer? Pick and pay. Even if you look at the pie chart, same thing. You look in the red, you see, before you even look at what the red is, you already know, okay, most people prefer the red. And then you see, oh, okay, right. So if we're SPAR, we already know who are our competitors, or should I say, who the customers prefer. And we need to then study our competitors and then begin to say, how do we get more market share, or how do we get more preference, right? What are they doing right that we aren't doing, for example? Okay, so we don't need to read this, okay? Then we've got cross-tabulation tables. Okay, so here, again, we are looking at, trying to see what is the information telling us, but via a table. So here, the table shows the number and or percentage of observations that jointly belong to each combination of categories of two categorical variables. Okay, hey, statistics, they use fancy English, but these are simple things. There you can see, there's our table, right? And what are our two categorical variables? Male and female. Okay, so we've basically just taken that initial table that we were looking at earlier, and we've now said, oh, before we had 10 people who preferred checkers. Now we're actually splitting it to say, but how many of those were male? How many were female? Can you see? And then we go to Pick and Pay and SPAR, and we do the exact same thing. We still have a total of 30 people. Okay, so again, nothing fancy here, nothing complicated. So this is why I was telling you, go and look at this stuff, go and read it, try and understand it a little bit, and then we discuss it together. Because then you realize, it's not that deep, okay? And that's what this module is all about. It's just understanding what is actually going on. How do I then apply a formula? And then voila, you're good to go. So here now they're just showing us that we have different ways in which we can express the same data. Okay, so you've got your bar chart, multi-bar chart. Okay, so here in blue we have the females, and in red we have the males. Okay, I would have assumed those colors to be the other way around, but anyway, doesn't really matter. Okay, then here we have what we call a stacked bar chart, and so here's the same thing, but we just said, okay, we'll put on top the males, okay, and then the females in blue at the bottom. And obviously this is doable because at the end of the day we're saying how many people prefer checkers. Okay, of males it's 7, and then obviously of females it's 3. Okay, right. So when you're doing this type of thing, when you're looking at your data, and it's a lot of data, you simply are just asking yourself, what's the easiest way to summarize my data visually? Okay, that would be easy for my audience to interpret what's going on over there. Okay, so here now they've just, instead of counting, they've then just put percentages. Okay, remember we had okay, yeah, so here you can see in each row they're saying of the 10 that we counted for checkers, 70% were women and 30% were males. Now obviously, again, remember we saw here at Pick and Pay. Pick and Pay had the most, right? Most preferences, okay? Or most, it was the top preference for customers for a grocery store, okay? And here already, what trends can you see? What trends can you see? Between males and females, hint, hint. Females are more. Okay, so your customer base in general in the industry for grocery stores are what? Females. So how should we be tailoring our marketing? How should we be tailoring our products to speak to? Okay, so again, you can see this percentage thing also kind of helps you to see certain information that maybe counting wouldn't be so easily to pick up. Does that make sense? Okay, all right. All right, right. So yeah, very interesting stuff. And so now I think it's really coming to life what we mean when we say statistics and the different methodologies and techniques that we can use here, it really just helps you to make decisions. Okay, so summarizing numeric, all right? So there we were looking at summarizing categorical. In other words, non-numeric data. Now we're looking at numeric, right? So here we can use a numeric frequency distribution. We can use a histogram. Who knows what a histogram is? Anybody? I see that smile on your face. You're like, ah, it's too organized. Yes, you. You forgot. Okay, so you guys tell me. Is it somewhat like a bar chart? It's similar, okay? Anybody know what the difference is? Bunch of geniuses. I'm lecturing a bunch of geniuses. Okay, so as you guys have highlighted, so rightly highlighted, with a bar chart, you've got the spaces. With a histogram, you don't have any of the spaces, okay? All right. So here they're talking about single numeric variables, okay? Numeric frequency distribution summarizes numeric data into intervals of equal width, okay? So that's something we need to take note of. They should be of equal width. Okay, so here again, they're going into another example, this time obviously of a histogram. Before we can actually do a histogram, all right, we obviously again need to split our data into intervals. And you can see all the intervals are equal, okay? Then we do a tally just to count, okay? And then obviously we can do percentages, okay? All right, happiness there, nothing complicated. And then there's our histogram. So that's what it looks like. And there you can see this data is actually grouped. Can you see? 20 to 29, that's a group. 30 to 39, that's a group. All right? Okay. Oh, awesome stuff. So nothing complicated there. Let's keep going. Okay, so now they're just talking to frequency distribution, all right, as a percentage. Okay, so there you can see last column there, they put it together for us there in percentages. Okay, so you can see that there's several ways to play around with our data and display our data. Percentages are always nice because it allows you to have a view of what portion of the entire pie belongs to this, that, and the third. Does that make sense? Okay. You then have what we call a cumulative frequency distribution. Okay. And a cumulative frequency distribution is a summary table of cumulative counts, which is used to answer questions of a more than or less than. Okay. So if you are kind of looking to think about how best should we utilize our resources in this regard or that regard, this is a very convenient means of looking at your data. Okay, so an ogive, and I don't know if I'm pronouncing that right, but an ogive is a graph of a cumulative frequency distribution. Okay, and I want us to look at this. So again, we've grouped our data. We've counted how many fall into the respective groups. We've got our percentages, okay, right? We've got our percentages. Okay, so this is now the cumulative aspect, okay? There's your frequency distribution, then here's the cumulative aspect. So can you see here, first from 400 to less than 800, we have 7. But now here we look at it as less than 1,200, we have 21. So we're basically including the first group and the second group. Can you see that? Okay. Here we were just talking about frequency distribution. Here we're saying cumulative. So we say up until the upper bound of the next group. That's the total number that we're looking at. And even here, from a percentage standpoint, you saw that in the frequency distribution, we had 46.7. Here we now have 70. Okay, we go to the second last one, 29. All right, we had a total of 30 people who were involved in this study. All right, I don't know if this is still the survey. Oh yes, it is still the survey, but now we're looking at grocery spend. All right. So how many people spend between what brackets? Okay. So you see that 29, right, out of the 30 spend between, well, less than 2,000. Okay. They spend less than 2,000. All right. So that's about 96% of, you can even actually say 97% of the surveyed customer base. So already you can begin to say, okay, goods that are obviously more than 2,000 or 2,000 and more, we don't need to shout too many of them because not too many people are going to buy. Can you see that? So that is helping us inform our decision now. Where should we focus more or less in terms of pricing? And then this is the ogive. So this is just now displaying the same information, but by means of a line. Okay? So if you look at it, can you see that at the very end of our graph, we're at 100%, which reflects the total data or the total population or the total surveyed individuals. Okay? So again, we can say, okay, how many people spend about 2,000? And there you can see that's about 98. If you're looking at the graph, it looks like about 98%, almost 100%. We can go to any random. How many spend, let's call this 1,250, okay? Although this should be 1,200 based on the information we saw prior, okay? And you can see that's about more than 70, maybe about 73, 74. Yeah, more than 70, okay? So again, you can quickly have a snapshot and begin to see you're more than or less than according to the data you're obviously investigating or seeking to extract information from. Okay, then we have a box plot, okay? And a box plot visually displays the profile of a numerical variable by showing the minimum and the maximum values and various intermediate descriptive values such as quantiles and medians. Okay, so I'm just going to draw the image. I'm just going to draw the image quickly, but we will come to understand this thing a little bit more when we actually go into learning unit. Sorry, when we go into exercises. So on the outskirts, you'll get the maximum and the minimum, okay? Then you also, then here you will have what they were talking about in terms of intermediate descriptive values. I'm sure you guys have seen an image like that, okay? So it's just to recall that that's what they are talking about, okay? Max and min, okay? Oh, min should actually be an N. Let's pretend like. All right. Hey, you guys are too serious today. Has it been a long day? So, is this the one with the Q1? Yes, because the Q1s and the Q2 and the Q3, that will basically be falling in. Let's go there. So Q1, I don't know. I don't think there's one in the slides. Then Q, I think it should be somewhere here. Q2, which is half of the data. And then this is Q3. Yes. Okay. Yeah, so this is that, okay? But again, we'll have a more detailed look at that. Okay, so again, we are still continuing to talk about numeric data over here. And here the focus is just speaking to the scatter plot, okay? I have a scatter plot for you guys here, all right? And I'm sure we've seen this when looking at maybe linear regression, which I know we've done both in high school and in primary. Is it fair to say that? Did you guys do linear regression? You didn't do it. Calculating, what do they call it? the line by getting your x1 and x2, y2, y1, that jazz. Okay, don't worry, we're just recapping here. We will jump into these things. So now I just want you to visually see, oh, okay, this is what we're playing with. Okay, and I love this graph because here we're looking at income and happiness. Okay, does happiness increase as money increases, guys? Does it? Huh? It depends. Why do you say it depends?
You're gonna buy a big house and you forget that you got text and then
Mm-hmm.
you buy your text again.
Mm-hmm.
So no, it depends.
So you
then,
can.
Then let's just stop and we have
So so me and my friends, that money that's a burden to you, just give us. Just give us. Because we don't seem to have that same problem, eh? Okay.
No, I was saying it depends.
Mm-hmm.
The more responsibility you have,
Yes.
then you have.
Okay. No, I hear you. I hear you. Okay, it's not a more money and then unlimited happiness. Here you can see happiness is increasing on the earlier side, but as we keep going, it's not increasing as significantly. Your happiness. Can you see that? Okay. Right. But anyway, yes, I love this for that reason. Right. Then the next graph that we had was a trend line. Okay. And a trend line is just to show us what is the pattern happening here. What is the general movement? Okay. What trend? I was trying to run away from the word trend that we are seeing over time. Okay. Because it's always about over time. There we were looking at sales. Here you can look at this and say maybe this is a index of a stock. What do they call it? The stock price. Yep. All right. So fortunately, there in that business, sales is going up as the year is progressing. All right. And here the stock is increasing in value over time. Those are the trends. Okay. So you could be asking yourself, should I invest in this stock? What's the trend? Is it increasing in value or is it decreasing in value? If it's decreasing in value, are you going to invest in it? You're not going to invest in it. Okay. If you are to invest in a business, right? You want to know, are they making sales? Is there revenue coming in? Are you going to invest if there's no sales? Okay, so again, we're seeing how these trends or this graphic representation already is helping us to make good or decisions, should we say, decisions, okay? So here they just speak to the Pareto curve, okay? Something I'm sure you guys have touched on in economics, eh? Anybody recall? Don't worry, we're not going to high school, eh? Uh-huh. Okay, so now here, we now are talking about grouped versus ungrouped data. Grouped versus ungrouped data. Okay, so what is ungrouped data? Ungrouped data are data that are not organized or if arranged could only be from highest to lowest or lowest to highest. That's it. That's group data. Sorry, ungrouped data. Group data, however, are organized and arranged into different classes and categories. So you remember when we said 20 to 29, and we said 30 to 39, and 40 to 49, that was grouped and organized. Does that make sense? If we were just to say we have a 24-year-old, we have a 32-year-old, we have a 64-year-old, we have a 55-year-old. Can you see how that information is just all over the show? But the moment we start to put these together, we're then obviously grouping the data and adding some organization to it. So here are some characteristics of the two types of data, right? So differences, okay? Grouped, organized in classes, okay? That we've already picked up. No form of organization under the ungrouped. Preference, preferred when analyzing data, okay? Because we want to see patterns and trends. So we want to see, so for us to conduct that analysis, we obviously would prefer it grouped, all right? Preferred when collecting data, all right? It only makes sense when we are collecting the data because we haven't yet decided how we want to analyze this data, all right? So if we haven't decided how we want to analyze the data, then we want to group it ourselves so that we can then conduct the necessary technique or analysis, okay? So if it's already grouped, then that becomes problematic because we then have to ungroup it and then do execute the correct grouping or the ideal grouping. Then accuracy has higher accuracy levels when calculating mean and median, okay? We're going to look at that soon enough. And then less accuracy in determining the mean and median. All right. Presentation frequency tables are mostly used for group data. We looked at quite a few frequency tables, both cumulative and then just regular frequency distributions. All right. Lists are used in this data. Okay. We say, what are the ages of our customers? And we just list. Okay, we've got 24, we've got 32, we've got 54, 64, etc, etc. Okay. Then summary. Summarized in frequency distribution, no form of summarization. Okay. There's no form because it's just scattered, it's everywhere. All right. Does that make sense? Right. So there's a nice overview of grouped and ungrouped. So here you can see this is what we're talking about. Ungrouped. 95, then 67, then we're here at 52. It's all over the place. All right? But we've collected it. Okay? We've collected it. Maybe we did a survey on the ages of students at Varsity College. All right? 69. Never would have guessed. All right? And then now we group the data, and there you can see 20 to 29. There's your frequency. We've got 3 of those. Okay? So already you can see it's taking shape in terms of getting organized. All right, all right, all right. Then numeric descriptive statistics. Okay, we've got measures of location. Okay, both central and non-central. We've got measures of spread, dispersion, and skewness. These are the things that we are going to obviously touch on before we leave today. Okay. Now, when it comes to location, we are just referring to data values that are centered. Where are they primarily located? Okay. So this is where you find the average and the median. Okay. Because average, we're saying values that, what is the average value that we get out of this data? Does that make sense? So you can see most of the values are located around that average. Does that make sense? Okay. And same thing with the median. Okay. Central location is a representative middle value of concentration of the data, while non-central location measures identify the relevant off-center reference point in the data, such as quantiles. Okay, we spoke a little bit about quantiles. We will see them a little more as we go down. Dispersion. This is now talking about the distance of the data values spread away from the central location value. In other words, like the average, for example. Okay, how far away is this value, this random value, from the average? Skewness. Okay, you'll see the shape of the skewness, I think. All right, but here it says identifies the shape or degree of symmetry of the data values about the central location measure. And remember, I spoke about the bell shape. Okay, you'll see when we talk about skewness, it is very closely related to the bell shape. Okay, and I will tell you how to identify whether something is left skew or right skew. I think oftentimes we complicate how we look at it, but there's a simple way of identifying it. Okay, so here, as I mentioned, central location measures. Okay, central location statistic is a single number that gives a sense of centrality of data values in a sample, okay? So when we talk about a sample, we know a certain portion of values, okay? Then three commonly used central location statistics are the mean, in other words, the average. We've played around with this our whole lives. The median, okay, we know it's the central number, okay, within the numbers that we have once they have been ordered from least to greatest. And then the mode is the most frequent, all right? So all of these are different central location statistics. Okay, that's fine. Okay, so here they're just giving us some examples. They've given us a data point and then they just calculate the average over there. Okay, there is our example. Okay, and here they're looking at the average fuel consumption of 20 trucks. Okay, that's what they're looking at over there. Okay. All right, this I think you guys can go read on your own. Just the disadvantages though. It is not appropriate for categorical data. In other words, non-numeric data. Okay. All right, and then it is distorted by outliers. Outliers are when you have extreme values. Okay. So for instance, if you check pass rates, somebody gets 10%. Then you get another person who gets 95%. And then you got most of the results between about, let's just say 60, 70, thereabout. The 95% and the 10% are outliers. They are extremes. But they are going to affect your average. Can you see that? Okay. So they distort. The mean is distorted by outliers. Okay. The median, however, because you're looking at the central numbers, okay, and maybe it's easiest to see this by way of an example. Okay. So here you can see the data was not organized. Then they organized the data from least to greatest. Okay. So what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's an odd number. So we look immediately at the central number, okay, the middle number. All right, and that's easy for odd numbers, but you'll see what we do for even numbers in the next few slides. Okay, but here you can see it's not influenced by the 12, which we can, and this is not necessarily an outlier, but let's say if we had, let's say 12, you can say is an outlier. It's quite far from 23. If we had 70 over here, that would also be an outlier. Can you see it's far out from the next value? Okay, so here you can see we just said what is the middle one, so it's not affected by outliers. Okay. Right, the median, that is. Okay, here we've got a data set where there is 10. Okay, so what we then do is we have to take the middle two and then we divide those by 2. We add them here, you can see 27 plus your 34, and we divide it by 2. So our median is actually 30.5. Can you see that? Okay. So just a quick recap. I'm sure you would have done that in school at some point. Okay. All right. Let's just see here. Okay. So here they're just talking about how to calculate the median from a graphic perspective, but that's fine. I don't think we need to do that now. So I'll end off here, and then we'll jump into the mode when we get back together again. The median, the two major drawbacks. It cannot be calculated for categorical data. The median, just like the mean, can only be applied to numeric data. Then lastly, the median is more affected by sampling fluctuations than the mean, as it uses only the middle data values and not all the data values, and is therefore less stable than the mean. Okay, so it's less stable than the mean because it does not include all the values in the data set. Right, ladies and gentlemen, are there any questions? thoughts, concerns before we call it for a break? Nothing. It's easy stuff, ne? Easy stuff. Easy stuff. Yeah. Child's play we're dealing with here.